Okay, here we go. So 13.3, this stuff from the Jacaranda text is replacing what's in your booklet, right? You're not using that, what's in there, except we're going to use this crazy, later, we're going to use this crazy thing that we made. I'm recording. So let's look at what this says here, and this will help us out for starting. It says, let's say that we're interested in the following collection of balls as you see in figure 1. There's 20 there, and a quarter of them are red. That means that the population, that's the whole population parameter, P, is 1/4. We knew that before we started doing this, right? Then in figure 2 it says, normally we wouldn't know the population parameter, so instead, so we wouldn't know that, instead we'd choose a sample from the population and we'd determine the sample statistic. In this case, we're going to use a sample size of 5, so those 5 are there. So little n is 5, and in our sample there, it turns out that there's 1 out of 5. So we call p hat the sample proportion, 1/5. A different sample could have a different sample proportion. So in this figure 3 down here, for instance, we pick this one, and it's 2 out of 5, p hat. So this p hat can change depending on where I take my sample or how many samples I take. It's a variable thing. In figure 4, it's 0. It could be 1. I could pick all the red balls. Okay? So these samples show what p hat is and how it changes. Okay? So the sample proportion p hat is equal to the number of successes in the sample over the sample size. The bigger the sample size, the closer p hat will become to the actual population proportion. Easy? Cool. Let's go. Just really quick binomial distribution revision. So what we know already. So this whole chapter is binomial. Okay? It's success and failure. So here we go. The population of success in a population is called P. It has a constant value. We've already done this. It's in our calculator. And we know that Q, or 1 minus P, is the other one. So when we did our left hand and right hand the other day, we had, it was 0.4 that we would pick a left-hander and 0.6 that we would pick a right-hander. You know what I'm talking about in this crazy thing we did? Okay? And so those are my P and Q, 0.4 and 0.6. The sample size is N. The number of successes in the sample is big X, and that's why we do that thing that says, what's the probability that big X is greater than 0.2 or whatever, something like that. You know, that's how that big X comes in. And the proportion of successes in a sample, okay, those are going to be our p hats. Those are just going to be in a sample. So let's do this example. It says, so this section explores what happens when we take lots of samples with replacement, so we're not taking all these balls out, we keep taking them out. We're taking them out the set, and then we're putting it back in for the next, okay? So, for example, suppose we have a population of 20 balls, 5 red and 15 blue. I'm just going to highlight that because we'll probably use that in a bit. Our experiment is to choose 5 from the 20. So that's how big ours is going to be, just like in our last one. We can now show the distribution of p hat. Okay, so in the olden days, we had a probability distribution table where this was X and this was the probability of getting X. Yeah? Now we're talking about the probability of getting a certain p hat. So it's a totally different table. Okay? This is the p hat are the things that I could get. So in my last picture, all those pictures I showed, I could get 0. I think this was red. Red was the thing I was getting. So I could get 0 red. I could get 1 out of 5 could be my p hat. 2 out of 5 could be my p hat, and so on. And these little things here are very interesting. So let's figure this out. To get this number here, the denominator for all of these is big N, choose little n. So in this case, it's going to be 20, choose 5. For every one of these, that's the denominator. And then the numerator is the choices out of the 5. Out of the balls that I have here. So there's 5 red in the 20 and 15 blue. And so in my sample of 5, I'm hoping out of those 5 red to get none, and out of the 15 to get all 5. See where I got these two? So out of that big population, that's what goes in the numerator. I don't want any of the red, and I want 5 out of the 15 of the blue. So I'm going to grab my calculator now, and I'm going to use this alpha F2, because that's where the NCR is, number 8. It's like a little shortcut. So alpha F2 will get you that shortcut, number 8. And I'm going to go 5, choose 0. Well, I know what that is. What's 5, choose 0? 1. So it's 1 times, and then I'm going to do 15, choose 5. Over 8, 20, choose 5. So it's that divided by that. See it? 0.194? Okay. So that's how they got all those numbers. Your book doesn't really explain that. So I'm going to pause this for a second. I'm going to stop.